this video, we are going to talk about trigonometry ratios. There are three main trigonometry ratios that we shall be dealing with. They are sine, cosine, and then tangent. So these are the three trigonometry ratios that we shall be dealing with. Now, before we talk about these three trigonometry ratios, let's first of all talk about Pythagoras theorem. Now, Pythagoras theorem mainly deals with right angle triangle. This is a right angle triangle. It always has 90 degrees at one side. So this is a 90-degree sine. And then this side, the longest side, is the hypotenuse. The opposite to the other side is the opposite to it. And then this is the adjacent. So we have the hypotenuse. We have the opposite. And then we have the adjacent. So these are the three sides that we have. The three sizes that we have for right angle triangle. Now, according to Pythagoras theorem, the square of the hypotenuse should be equal to the square of the opposite. Okay, let me put magnitude here. The square of the magnitude of the opposite plus the square of the magnitude of the adjacent. So this is how it is. This is what Pythagoras states that, okay, let's say I want to move from, let's say this is point O, let me call this X, let me call this Y. Pythagoras is saying that if I decide to move from point Y to point O, then finally to point X, the time taken or the distance that I'll cover will be the same as the time taken to reach the apex, that is that side X, will be the same as somebody that travels directly from Y to X. So going from Y to X is the same as going from Y to the origin, which is O, then from O to the apex, that's X. So that's what Pythagoras actually states. So here we shall be dealing with change of subject. Let's say we want to, so this is the formula. Let's say we want to find for the opposite. Now, because we are looking for the opposite, it means that we need to make the opposite the subject. So here, the hypotenuse minus the adjacent squared will give us the opposite squared. We have made the opposite the subject of the equation. We have made it, before it was the hypotenuse, but then we have made it the subject of the equation by moving the adjacent to the side of the hypotenuse, thereby becoming a negative, or thereby, yes, having a negative sign because it has crossed the equal to sign, so the sign will change. So that's all about Pythagoras theorem. Now let's talk about our trigonometry ratios. Now, the trigonometry ratios are also in connection with the right angle triangle. They can be used for other triangles as well, obtuse, scalene. They can be used for all triangles, but mostly they are used for right angle triangle. They are used for right angle triangle. Yes, they are used for right angle triangle because it is very easy to notice the hypotenuse side. So let's say this is our A. Now, sine, let's say this angle is angle theta. So sine of theta, if I want to find sine of theta is always equal to the opposite, which is O, over the hypotenuse. That is sine. And then cos is also related or associated with, cos is associated with the adjacent side. So cos theta will be equal to adjacent over hypotenuse. So whatever the value of A will be, you just put it at where it is. So this is the formula for cos. Cos is always associated with the adjacent side, and sine is always associated with the opposite side. So now let's move on to tangent. So let's say we want tangent theta. Tan theta will be equal to, here it is the opposite over adjacent. So opposite over adjacent. So that is how the trigonometry ratios are applied. So now let's try and see if you can use that to solve some questions. So I have, let's make this side 5, and then this side x, and then this side, okay, let's change it. Let's make this side 10, this side x, and then this side y. So we are going to find for the variables. Now let's say the angle is 20. So let's find for sine 20. What will sine 20 be? We want to find for the value of y. Since y is at the opposite side of the hypotenuse, we are going to apply sine, because sine is associated with the opposite. So we have sine 20 is equal to our y, that's the opposite, as we said earlier, over the hypotenuse, which is 10 over here. So we make y the subject. So y is equal to 10 sine of 20. Therefore, y is equal to 10 sine 20. You point that on your calculator. Sine 20 is 3.4. That's to 1 decimal place, 3.4. So that is how we can find for y. Let's try and see if we can also find for x. To find for x, we use cos. As I said, cos is associated with the adjacent, and x is at the adjacent position. So we have cos of 20, because sine the x position is near. Okay, adjacent means near. It's close to the angle under consideration, which is 20. So x is the adjacent side. So here we have 20 is equal to the adjacent over the hypotenuse, which is 10. We make x the subject, so change of subject has come in. Then we have 10 cos of 20. You point that on your calculator. 10 cos 20 is 9.4, approximated to 1 decimal place, is equal to 9.4. So this is how we can find for the variables. Also, let's say we want to find for tan 20, and I'll leave this for you to do. So tan 20 is equal to tan 20 will be equal to the opposite, which is y. Now we have the value for y all over the value for opposite over adjacent. So this is it. So just substitute the value for y and then also x into it, and then you are gone. So this will be all for this lesson. Thank you very much. Bye.